All right, hello again. Now for two people. So we're going to start talking about quadratics today, and this first day of stuff is really just going to be kind of about the general kind of aspects of a quadratic. So let's start by talking about the parent function, which we saw a couple weeks ago, just with all the parent functions. Remember, the basic parent function is just y equals x squared, right? And it looks like a parabola, that kind of U shape where the bottom is at the origin and all that good stuff. Okay. Remember the domain of that, all real numbers, from negative infinity to infinity. And the range of the parent function is just from 0 to infinity. We're going to generalize that in just a minute. So just we can define the range of any quadratic. But before we do that, we need to talk about a couple different things first. So the quadratics actually have three different ways that we can write them. The first way is called standard form. We're not going to see that a whole lot in this unit, but when we go forward into the next chapter, we're going to see this a whole lot more. So standard form is like ax squared plus bx plus c, where a, b, and c can be whatever. And again, we will see that form a little bit more later on. But what we're going to be dealing with a lot in this unit is what's called vertex form. And it's going to look a whole lot like transformations that we've already seen in some other functions. So vertex form is a parentheses x minus h squared plus k. Okay? And again, think of this in terms of transformations. So my a, we know what a does, and the h and the k. But the reason it's called vertex form is the vertex is that number h and k. Okay? So if my vertex is 0, 0, that's why it says y equals x squared. Anything the vertex is, if we're going left to right, up, down, whatever, we can write it in that way also. Parabolas also have this thing called an axis of symmetry. Basically, it's a vertical line that kind of chops it in half, right? So for the parent function, the axis of symmetry would be x equals 0, but in general, it's just going to be x equals h. We'll talk more about that too in just a minute. Okay, so let's kind of remember what this means in terms of transformations. Okay, so remember the a value does a couple things. So first of all, if the absolute value of a, just the number itself, if it is greater than 1, then that means it is a vertical stretch. And if it is between 0 and 1, then it's a vertical compression. Remember, I use the absolute value there because it's just the value of the number itself. If a is ever negative, so if a is less than 0, then it's a reflection across the x-axis. So that's everything that a does. And remember, going across the x-axis basically means upside down. H, if you remember from your parent functions, or even from the last unit on absolute value functions, remember H is our left and right shift. So H is shifting left to right. And remember, it kind of looks backwards when you see it in the equation, and we'll see some examples of that in just a minute. And then K is your up and down shift. Okay? Good news here on the domain, folks, for right now, the domain is never going to change. It's always going to be negative infinity to infinity. Okay? When we get into some application problems, again, in the next chapter, we will restrict the domain just to make it make sense, kind of logic wise. But for right now, the domain of any quadratic is all real numbers, negative infinity to infinity. But the range does change if you're part of the rhyme, okay? And it's always going to change according to the k value, okay? So it's going to change with k value if it shifts up and down, okay? If a is positive, I don't care what it is, if it's greater than 0, then the range is k to infinity. If a is less than 0, if a is negative, remember that makes it upside down, so it basically flips the range upside down if you want to think of it that way, and it's going to be from negative infinity to k. Okay? And obviously the a value can also affect what the vertex is. Okay? Because again, if you think of it, if a is greater than 0, so if a is greater than 0, then your parabola is kind of going up like this, right? It's opening up. So that means the vertex is going to be a minimum value. And if a is less than 0, now the parabola is going to be opening down. So now my vertex is a maximum value. And then the axis of symmetry, and it's up here also, but I'll write it down here again. The axis of symmetry is always the same. There's nothing you got to remember about that. It is just always x equals h, that x value of the vertex. Okay, so what do these things look like? So I'm going to draw a couple of examples. Let's say a is greater than 1, right? And say, greater than 0 rather. So let's say a is positive, so it's going to open up. And I'm just going to make one up, doesn't matter. Let's say it kind of looks like this. Okay, so it opens up. My vertex there is a minimum. I'm going to pretend for a minute, I'm going to pretend that's a point -1, -1. So in this case, the range would be from -1 to infinity. How about if a is less than 0? Well, that means it's going to open down. And let's say this one looks like, and again, I'll just kind of make one up. Let's say it looks like this. And I'm going to say that's the point, I don't know, how about 1, 3? Notice that's a maximum. And the range would be from negative infinity up to 3. Again, always that k value. Okay, so that's really all I want to talk about today. Let's run through a couple of examples. I'll do the first two, then I'll let you pause the video, and then we'll kind of type a couple of loose ends for the couple of them on the back page. So again, all these things are going to be in vertex form. Remember, this is always the a, the h, and the k. Don't forget to change the sign of the h. So the vertex here will be +1, 5. Since a is greater than 0, it's positive, then it's going to open up. It's going to be a minimum. So again, opening up, minimum value. But the key word here is value. If you ever get a question that says, what is the minimum value of the parabola or of the quadratic? It is talking about the y value only. Okay, so the minimum value would be at y equals 5. Axis of symmetry is always x equals h, so x equals 1. Domain, always negative infinity to infinity. And the range, again, just kind of visualize it opening up. So it goes from k up to infinity. So 5 to infinity. By the way, it is always going to be a bracket on that k value because it's going to touch that number. How about letter B? Vertex. Change the sign. So again, that's A, H, and K. So my vertex is negative 2, 1. A is negative, so it's going down. Since it's going down, it's going to be a maximum point. And again, y value. So max value would be at y equals 1. Axis of symmetry, x equals h, so it's negative 2. Domain, not even going to say it out loud because it's always the same. And then the range, again, think of the range as being upside down also. So negative infinity to k, in this case 1, with a bracket. Okay. So if you need to go back and watch a couple of those and make sure you see where those numbers are coming from, please do that. But here's a couple other questions for you. So if you can pause the video real fast and do example C, D, and E if you haven't done them already in class, and then I'll zip through those answers and we'll type a couple loose ends at the bottom here. All right, letter C, let's check your answers. So vertex, negative 3, negative 7. It's opening down because of the negative in front. So it's a maximum value at y equals negative 7. Axis of symmetry, x equals negative 3. Domain, always the same. Range, negative infinity to negative 7. For part D, by the way, don't be afraid of 0, because if there's nothing out there, then it's 0. So my vertex here is 4, 0. Direction going up, A is positive. Since it's going up, it's a minimum value at y equals 0. Again, that k value. Axis of symmetry, x equals 4. Domain and range, 0 to infinity. And then for part E, this is a verbal description. So we need to take a verbal description and write the equation. So it's being reflected over the x-axis and shifted up to. So that's going to be y equals negative. If you want to write it as x minus 0, because it's not going left and right at all, totally okay. You could just write that as negative x squared. And then up to would be plus 2 on the outside. And then same question, vertex 0, 2. It's going down. So it's a maximum value at 2. Axis of symmetry, domain, and range. Okay. Last thing today that I want to cover is again a little bit more info about things that happen with quadratics and functions in general, really. So if you remember back in algebra, there were 4 names when a function crossed the x-axis. So like if you look at like this picture right here, the guy in purple, what do we call that point and that point, if you remember? Well, it has 4 different names, and you can use any one of them. They're all interchangeable. We can call it a 0. We can call it a root. We can call it a solution. Or we can call it an x-intercept. They all mean the same thing. I will use all 4 of them interchangeably. Textbooks, questions, test questions, whatever. They all mean the exact same thing. It's just where the function crosses the x-axis. So if we're talking about parabolas, how many times, what are the different cases of how they could cross the x-axis? Well, first case, it could cross it twice. And we've already seen that on what I drew on the front page. So it could be going up and maybe cross twice, kind of like this. There's your two zeros right here. Or it could be opening down and crossing two places, something like that. It could also only touch the x-axis in one case, in one place, I should say. Now think about this. If it's only remember, it doesn't have to cross the axis. As long as it touches, it still counts as a solution or a root or a zero. Okay, so what would it look like if it only had one solution? Well, if it's opening up, that means the vertex would have to be right on the x-axis. That's your one solution. Or same thing, if it's opening down, the vertex would still have to be right on the axis. Okay, now to be kind of nerdy for a second, these still do technically have two solutions. It's what we call a multiplicity. We'll get into that later on. And then finally, we have one that we're with no solutions, but I'm going to add another word in here. It's not just no solutions. I'm going to call this no real solutions. And that's going to be when it'll never touch the x-axis. So again, we can have it opening up if the whole parabola is always above the axis, or if it's always below the axis. That's going to be the no real solutions case. Now, why did I put the word real in there? A preview of a little bit later on. We're going to see in about a month, we're going to come up with numbers, and we're going to learn about numbers that are called imaginary numbers. And so even these guys, even though they don't touch the axis, they still have solutions, but they are imaginary solutions. So we'll talk about that later on. The last thing for this video and kind of the intro to quadratics is I mentioned at the very beginning, there's three forms of a quadratic. We had standard form, vertex form, which we'll be dealing with mostly in this unit. And then we have this thing called factored form. Okay, factored form, this is what it looks like. Notice the A, it's still the same A that we've been dealing with the whole time. But now we have it in these individual factors where these guys, that M and the N value, those are the zeros. So it's, in other words, if you're in that form, you know almost automatically where the quadratic is going to touch the x-axis. Much more on this in the next unit, but notice for right now, and again, don't overthink this. We'll get into more detail when we get this form a whole lot more next unit. But for right now, we're basically solving each of those for 0. So if you put x plus 3 equals 0, so you got x equals -3, get x by itself. Same thing for the next one. So x equals 1. So those are your x-intercepts, or your zeros. So your point would be at -3, 0, and at 1, 0. And I know you're thinking, well, can't we just change the signs? Yes, for these, we will see some later on that'll be more than just changing the sign. There'll be one more thing to think about, but we'll do those later on. So the same thing for example 2. My zeros would be at -4, 0, and at -7, 0. Okay? So that's the intro to quadratics. Next video, we're going to talk about some other attributes called the focus and the directrix of quadratics. But we will do that next time. If you have any questions, please come into tutoring. Until next time, stay safe.